Welcome back to another one of my episodes in learning integration. This episode will be focusing on integration by parts and the natural log of x function. So here we have a title, obviously, and here we have a function. The first derivative is ln of x, and the original function is x ln of x minus x plus c, because that's still the same as integration. So the integral of ln of x is x ln of x minus x plus c, and here is the formula for integration by parts using Leibniz's notation. Let's get started. Example 1. We'll have function, the derivative will be sine x multiplied by ln of x. Now if we were to derive anything inside the brackets here and multiply it back in, it wouldn't help us eliminate any of this. Therefore we use integration by parts. So we find the integral of both sides, basically getting rid of the derivative on this side, and we use the integral symbol here. Now we'll show you a few different, we'll show you a new technique, not really a new technique, but a technique that I don't see often, that I think people should know a bit more about. I'll put that in both of my examples. But here we have what we want. We want to compare this to this. So one of these has to be u, and one of these has to be the derivative of v. I usually always say, if you've watched my other videos, that u should be something that'll simplify easier, because we have a u dash. So we want something simple to multiply under this v. But when we have ln of x, I choose that has to be u, because if you make it v dash and we have a v, that means we have to find the integral of this. And this is not simple to deal with. This is a pain in the ass. Therefore, it'll be easier just to derive this and leave this to be integrated or anti-differentiated. Okay? So because we need to find a u, a v, a u dash, and a v, well, I said v twice, but we need to find it. We have our u, we have our u dash, we have our v, we have our v dash. Okay? We've selected u to be ln of x, and we've selected our v dash to be sine of x. Our derivative of u is 1 over x, and our integral of sine x is negative cos x. I would say plus c, but if you've watched my other videos, you know I don't like to put the plus c here because it creates too much work in the middle. I want the plus c's and whatnot at the end. But anyway, we have this. This here is our formula. We're going to make this. We have this side, which is here. So I'll write that out. Integral sine x ln of x dx equals. Now we sub in this. U we've set as ln of x. V dash we've set as sine x. Not v dash, v, my bad, is negative cos x. Minus the integral of u dash being 1 over x, multiplied by v, multiplied by negative cos x dx. Okay, now that we've written out our formula, you can see here that if we just rewrite this, once we've simplified this, it doesn't change until the end. So negative ln of x cos x, okay, and subtract. Well, we have 1 over x multiplied by negative cos x. Now, multiplication by constants means we can actually get rid of this negative, because we pretend like it's an invisible, we act because it can be an invisible -1, because -1 multiplied by cos x is negative cos x. Therefore, there's a -1 in there. Multiplication by constants means we can bring it in front of this integrand. So if we bring the negative out and multiply it onto the negative, we'll end up with a positive. Then we're just left with integral of cos x on x dx. Okay? Hope that wasn't too much of a mouthful, but nonetheless. Okay, so that equals negative ln x multiplied by cos x plus. Now, the integral of cos x on x, you basically just write it with a capital C, a little bit of a writing I, x. And this here signifies this all here. Okay? This says the integral of cosine of x. Cosine of x on x. That's what this right here signifies. Okay? May be difficult to get your head wrapped around, it might not be, but if you Google this, cos x over x, the integral of it will come up with this if you're looking in the right spot. And it will show you theories why, and it'll give you it'll give you the written theory of it, but this is it right here. Okay? And we're going to add a plus c on the end. Okay, so just remember that. It's the same when you have, I'll show you in the next example, I won't add on too much, but let's just rewrite this. So we have the integral of sine x multiplied by ln of x dx equals, we're going to bring the cix out the front because it's a positive, subtract ln of x cos x plus c. And that there is the integral of sine x multiplied by ln of x. Now I'm going to do another example. Example 2. And it's going to be, let's start off with the first derivative because I like doing that when I'm using Leibniz's notation. And that will be e to the power of x multiplied by ln of x dx. Okay, so we're going to find the integral of either side, and we should get something that looks a lot like this. Now, just like before, we pick one to be u and one to be v dash. Because there's an ln of x, I prefer this one. In this case, I prefer this one to be the u and this one to be the v dash. So u dash, v dash. Okay, remember that we need to find those in order to complete this formula. Okay? So u, we said that that's ln of x. The derivative of ln of x is 1 on x. V, we don't know v, we know v dash. V dash is e to the x. Integral is e to the x plus c. I don't like to write the plus c, so I'm going to leave it out. You should always write plus c if you're doing that as just a question, but by parts, I don't write it here. In this scenario, in this question, I don't write it here. I write it later on. Okay? So, let's write that out. We have our integral of e x ln of x dx. That equals, well, the formula said, if I can bring it out, that we need u ln of x, we need v e to the x. Subtract the integral of u dash, which is 1 on x, and multiplied by v. V is e to the x dx. Okay, so that's what we're left with. Now the first bit, I'll just rewrite it out here. E to the x ln of x dx equals, we're just going to rearrange this, only because that's the way I like looking at it, I guess. And the integral e to the x multiplied by 1 over x is e to the x on x dx. I hope you can see where this is going, but I'm gonna rewrite this out because this will be answering the question now. Okay, e to the x multiplied by ln of x minus. Now, just like before when we had cos x on x, that was a capital C-I x, that signifying that was it was the integral of cos x on x. Now we have e, the variable is x, and it's on x. If you search it up, you will find it to be a capital E, little writing I, and then an x. That signifies this up here. It signifies the integral of e to the power of x on x. I'm going to add a plus c at the end because you need the constant. Okay? And I'm not going to rewrite this. This is good enough for me. This, I hope you understand this technique. Well, not really technique, I hope you understand it in general, the way it's used. Thanks for watching this video. I hope you learnt something, and have a good day.